So in this lesson, we are going to look at neural networks. But one thing we need to be very careful about this particular lesson is we are not going to the science behind neural network. We are not going to see how it is going to work. It needs its own training. It is a very deep topic, and I'm planning a different training for that topic itself. For us to keep going, we are simply going into the overview of what is neural network. So this is the wiki page for neural network, and this is a simple image of a neural network. These round artifacts here are called neurons or nodes, and these arrows are weights, basically some numbers. Normally they are real numbers, which has decimals and points and things like that. Usually very small digits. Again, input is a layer of neurons, as you can see here vertically, and there are a lot of hidden layers here. This is a layer of neuron. There's a lot of hidden layers normally in neural network. This particular network right now in the diagram has only one hidden layer, and again output is another layer right here. This is the overall structure of neural network. Now, how any useful task like pattern recognition or anything like that is achieved by this simple looking architecture? That is a bigger question, needs a training by itself. But in short, what we are trying to do is we have a mechanism called training. So we have input and output, non-input and output. With the non-input and output or labeled data, that's what they call in the AI terminology, labeled training data, we adjust the weights. There is one more thing called bias, which I'm ignoring here. Adjust the weight and bias and something called activation function within the neuron. We adjust all these things using non-data. The process is called training. Training is also sometimes a part of learning. The neural network learns, and it is trained based on n input and corresponding n output, and it'll try to predict the output of n plus 1th input. That's how it is trained and inferred on the n plus 1 output. A lot of details I'm ignoring here. Not a lot of information I'm putting out here which is useful, but giving you a feel of how these things works. Let's skim through the wiki page so that you can read more about it, and I'll show you some trainings. I myself planning some trainings around it shortly after finishing this one. But till then, I'll give you some more information in case if you're interested how these things works internally. So the whole thing is highly inspired by the structure of biological neural networks in animals such as human beings. So it is a fundamentally different way of computing, trying to mimic the human brain itself. So ANN or artificial neural network is the abbreviation of neural network. So there are a couple of things to get your head around if you're getting into neural networks and machine learning: activation function, weight, bias, all these things. Weights and bias are normally called parameters, 70 billion parameters. You might have heard that in the case of these new LLMs coming out. That is nothing but these weights and bias. So normally the neural networks are aggregated into layers, something which I mentioned. And there are so many hidden layers, any number of hidden layers we can have. And it is used for solving the problems which we mentioned, pattern-based problems. So we have discussed about training of the neural network, basically adjusting the weights and bias such that it is useful for a particular purpose. That is the training of neural network. Basically, the training of neural network focuses on minimizing a cost function or a loss function. Again, not getting into the details of it, but it uses an important algorithm called backpropagation in calculus. A relatively straightforward process. I will mention some link in the description of this particular video. You can read more about it. Backpropagation, gradient descent, all that kind of fairly straightforward calculus approach, basically something called differential calculus. So this is a point I wanted to highlight here. Von Neumann model, that is the model of the computing we've been talking about, the EFELS thingy. This is the technical term for traditional computing paradigm. The memory, CPU disk, that kind of things we drew. In fact, we drew a von Neumann architecture. Pretty much this is the diagram we have drawn. This is the CPU and this is the memory. Input device, output device. This is the diagram we've been drawing. So there are certain things we can't do with the von Neumann architecture, like the things we discussed, the pattern stuff, which human does very easily. So neural network, on the other hand, originated from the efforts to model information processing in biological system through the framework of connectionism. This is nothing but they are talking about the neural network we already discussed. So it is fundamentally different from the von Neumann model of computing. It's a lot of details and histories. You can skim through it. I'll be mentioning some of the details so that you can read in the description of this particular video. So this is the normal neuron, our brain neuron. It has again multiple inputs and outputs, and this is what we are trying to emulate. So this is the cost function we've been discussing. The training is all about minimizing the cost function. And what is the algorithm we are using to minimize that? Backpropagation. Through backpropagation, we achieve something called stochastic gradient descent. So if we are really getting into AI, these are the things you need to learn. There is supervised learning, unsupervised learning, all details. It's a pretty big article out here. There's a Python sample to implement some of these things we discussed. This is weight and bias, things like that. So training a large neural network is very compute intensive. So we have to use GPUs. So training is mostly from a compute perspective. All it is doing is matrix multiplication or multiplication of different numbers. That's what the training is all about at the end of the day. Multiplying different numbers, mostly floating point numbers or numbers with a lot of decimal numbers. GPUs are very good in such kind of activities. They can do those things in parallel. That's why GPU is used for training a neural network. So recently, there is a lot of advancement in this particular domain, and it is used for image processing. We have seen facial recognition and things like that. Speech recognition, NLP, all the chatbots we have seen. A lot of different systems which is controlled by the AI, and the application is countless. So you might not have understood anything in this particular lesson, which is completely fine and completely accepted. This is not a training of a full-fledged neural network, which we need a lot more background to get into this topic. But we need to understand the models we are going to use in this training uses this neural network internally. This is what happens internally within them. There is an element of error when we compute with neural networks, which traditional computing doesn't have. 1 + 1 is always equal to 2 in a computer, in a calculator. Calculator never makes a mistake when you multiply two numbers. But that's not the case with neural network. Sometimes it gives a probability of error, and sometimes that probability is pretty high. So we'll see that when we start looking at different models. We'll get some things slightly wrong, but that's okay. We'll see how to tackle it down and go through it. So we have had a peek into what a neural network is. We have had a glimpse into it, not into any details. Like I mentioned, it needs its own training. Now what we can do is that we can see these things in action. That's what we are going to do next.